In this question, we're asked to determine whether this is a redox reaction and to identify the reducing agent and the oxidizing agent. I'm going to focus on that in this video. In previous videos that may be linked to this playlist, you can find descriptions of how to find the oxidation states of these different things and how to identify whether oxidation or reduction has occurred. But here I'm going to skip right to showing the oxidation states and then talking about oxidizing and reducing agents. So in this case, copper in copper sulfate is 2+. That's its oxidation state as well as its charge because it's a monoatomic ion. And then on the product side, it's 0 because it's an element. It's just elemental copper. Zinc, on the other hand, started out in oxidation state 0 and ended up in oxidation state 2+. So copper went from 2+ to 0. This means it gained electrons. This is reduction. Whoops. Reduction is gaining. And zinc went from 0 to 2+, which is losing electrons, which is oxidation. So zinc was oxidized and Cu2+ was reduced. The agents are the opposite of this. So the thing that is oxidized is the reducing agent, which in this case is zinc. The thing that's reduced is the oxidizing agent because it oxidized the zinc. So whatever it is, it's the opposite agent, if you will. And here, I think you could put copper 2+, but on the answer key they have CuSO4 as the oxidizing agent. And yes, this is definitely a redox reaction because things changed their oxidation states. Here we have a combustion reaction where for some reason the hydrocarbon is written second and then the oxygen is written first. Typically we put them in the opposite direction. In a combustion reaction, you can be pretty darn sure that oxygen will be the oxidizing agent, but I will prove that to you in just a minute. Here we have elemental oxygen, which is 0. And in both of these cases, the oxidation state on oxygen is -2. So I'm just going to write it up here, but it's the same for both cases. In this case, oxygen gained electrons, so it was reduced. Therefore, it is the oxidizing agent. It's called oxidizing agent because of combustion reactions where oxygen is oxidizing things, and probably other reactions as well. Let's look at what is the reducing agent. If we look at carbon here, in both these cases, the carbon's oxidation state is -3. And over here, in carbon dioxide, it's +4. So it has lost electrons to go from -3 to +3. From -3 to +4. So it is oxidized, where oxidation has occurred, so it is the reducing agent. Here, it's using CH3, which is ethane, as the reducing agent. It might be arguable whether just carbon could be considered as the reducing agent here, but we'll go ahead and put CH3 because the oxidation state of carbon went from -3 to +4. In the last example, we have sulfur, which even though it's S8, it is elemental. So its oxidation state is 0. To over here, where it has an oxidation state of -2, because that's the charge on sulfur in lead-4 sulfide. So it went from 0 to -2. So it gained electrons, so therefore it was reduced or reduction. And lead is elemental here. It went from 0 to +4, so it lost electrons, so it is oxidized or oxidation. So yes, this is definitely a redox reaction. The thing that's reduced is the oxidizing agent. So in this case, the oxidizing agent is S8, and the thing that is oxidized is the reducing agent. So in this case, lead is the reducing agent.